Everyone in the world we know doesn't have an infinite amount of resources. No single person has an infinite amount of money. So we all face a budget constraint, which means that not a single person can buy every single thing in the universe, basically. That's really all that we're saying. So in economics, we start we do define budget constraints for any individual consumer, which basically just all that it says, all that a constraint says is this is all of the different things that you can buy given your finite amount of income, given your finite amount of resources. So to do this in two dimensions, we only can use two goods, but the same idea does work for infinitely many goods. So in theory, and actually really in practice too, we can write out how many of any single good you can buy given your income. And the reason that this is important is that it represents the trade-offs that we are forced to make since we have only a limited amount of resources. We can't have every single thing in the universe, basically. So I don't think this is too abstract of an idea, and I think that it's easiest to just get down to an example again. So that's what we're going to do. So we have John that has an income of $60 a day. So I'm going to write I for income is equal to 60 to spend on apples and oranges. So apples are $3. So let's say the price of apples, P sub A, is equal to 3. And then oranges are $4. So P sub O is equal to 4. So we want to just write out an equation that represents these three things. And the easiest way to do it is that John's total income, so first I'm going to write this just in abstraction and then I'll write it for this example. So his total income always has to be equal to the price of good A times the amount of good A that you use times the quantity of A, and I'll put that in parentheses, plus the price of good B times the quantity of good B that you consume. So basically all that this is saying is that if you spend all of your money, your income has to equal the amount that you spend on good A plus the amount that you spend on good B. And remember, we're only doing this for two goods, but you could do this for as many as you would like. So in this example then, we're going to have that John's income is $60. So we have 60 is equal to the price of apples. We'll make apples good A and then we'll make oranges good B. So apples are $3. So we have 3 times the quantity of apples plus 4, and I'll do this in orange, plus 4 times the quantity of oranges. So I'm using an O instead of a B because O goes with oranges. So all that this is saying is that he can't spend more than his income. That's really it. So let's go find out then. The way that I like to graph budget constraints is I just like to find the two intercepts. So now let's go let's say John spends all his money on apples, on A. So he has then $60 is equal to 3 times the amount of apples he can buy, because he's not going to buy any oranges. So we know that this, I'll just write it out for the first time, he's buying no oranges because he's spending all of his money on A. This is just to find the intercept. So the amount of apples he can buy if he spends all of his money on apples are 20, just 60 divided by 3. So I'm going to go ahead, I'll put that this is John's budget constraint, we'll title it, and we'll have apples over here. And so he can buy 20 apples, and I know that this graph paper is 22 units tall, so 20 is right there. Now, same thing for oranges. So if he spends all of his money instead of on apples now on oranges, so I'll just do this in an O and we'll do this in orange right here, then we have 60 is equal to 4 times the quantity of oranges that he buys. And 60 divided by 4 is 15, so we have the quantity of oranges is equal to 15. So if we know this is 22, this is 21, 20, 19, 18, 17, 16, 15. And then if we just connect these two lines, we have John's budget constraint. So this is John's budget constraint, and I'll put for $60 right here because that's how much he had to spend. So now let's say that we cut his budget in half. So we slash this, and now he only has $30. Well, it's pretty easy to see that he's going to be able to buy at most 10 apples. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And at most 15 divided by 2 is, or 30 divided by 4, which is the same thing as 15 divided by 2, will give us 7.5. So we'll go 1, 2, 3, 4, 5, 6, 7.5. And we're doing that in orange. Whoops, I lost it. 1, 2, 3, 4, 5, 6, 7.5. So this will be John's budget constraint if he only has $30 to spend. And so it's pretty easy to see that as you get more income, you keep the slope exactly the same, and you just move out farther to the right. So there's one more thing that I want to do, and I want to show you what the slope of the budget constraint always is. So we have, in general, we have I is equal to the price of A times the quantity of A plus the price of B times the quantity of B. And so what I'm going to do is I'm going to rewrite this, and I'm going to make A the y-axis. So I'm going to write this as the price of y and the quantity of y, and I'm going to make B the x-axis because I think that's easier to understand. One thing I just saw is that I never labeled the x-axis, so this is oranges. And so now we're going to get back to our example over here. So we have I is equal to the price of y times the quantity of y plus the price of x times the quantity of x. And now I'm just going to solve for the quantity of y because that's what we're putting on the y-axis, and I want this in slope-intercept form. So the quantity of y, I'm going to subtract this entire term over to the left. So this is going to go over here. And so we are going to have the price of y times the quantity of y is equal to I minus the price of x times the quantity of x. And then if I divide this entire thing by the price of y to get the quantity of y alone, I get that the quantity of y is equal to I minus the price of x times the quantity of x all over the price of y. And so this tells me the slope of the budget constraint, and that is the negative of the price ratio, because that's what's being multiplied by our x right here. Imagine, the quantity of x is really what we're graphing on the x-axis, the quantity of oranges. So this is really x and this is really y, but I just like to put the q's there so that we know that it's the quantity of them that we're actually graphing. We don't get it confused with the price. And so if we had y is equal to some constant, I, just I divided by py, minus the price of x over the price of y times x, this would be our slope because we have this in slope-intercept form. So the slope of the budget constraint is equal to the negative of the price ratio. And this will be important later on. And then the other thing is that the intercepts, so the y-intercept, and I'll just write int, is just equal to income divided by the price of y, and then the x-intercept is equal to income divided by the price of x. And we saw that just when we were working through this example here, but I just wanted to make that clear. And then the very, very last thing that I want to say, I think I've probably said the last thing a couple times here, but I keep on thinking of other things, is that let's say that apples now get more expensive. So let's say apples also go to, I need a different color here. So let's say apples now also go to $4. Well, if apples go to $4, then we know that they are going to have the exact same intercept as oranges because we already found that out. So when we're doing on the 60-degree line, and I'll do this in, I guess I'll do it in this pink, we're going to go up 15. So this was 10, and then we need another 1, 2, 3, 4, 5. So this will be, we'll call this budget constraint 60.2 because we're changing things up a little bit. So if you increase the price of a good, that just shifts the slope. It shifts the slope of the budget constraint, and it will always leave one of the two intercepts the same. If you increase the price of both goods, then you'll change both of them, and I can't say anything in general. But it's just important to see that when you change the price of a good, that the slope changes. So here I increased the price of apples, and the intercept of apples dropped down, and then the slope here shifted. And it shifted in accordance with this ratio up here. Alright, that's all that I want to say about budget constraints. I hope that that was clear. If it wasn't, please let me know.